Hey, we will be learning about binary search tree and we will try to write a program to implement it today. We already know about the header file. Header files like IOStream using namespace std, the predefined libraries. So first, we will be trying to create a tree node. So, firstly, before moving on to the program, we will just have a recap on what is a binary search tree. So, you might be aware of what is a tree. Tree is something like which will be having a combination of vertices and edges. Vertices in the sense something like this, and edges in the sense the ones that links it, the line, the connection between the vertices is known as edge. And then comes binary tree, not binary search tree, just the binary tree. What is a binary tree? Binary tree have only two children, at most two children. It can only have 0, 1 and 2 children, not more than 2. It can't be more than 2. Alright, that is binary tree. Then comes binary search tree into the picture. So why do we need binary search tree when we already have binary tree? Because binary search tree makes searching easier, as the name suggests. Search, right? So how does this work? What is it? What is the technique for creation of binary search tree? How does this work, and how do we search any element in binary search tree? First, we will see what is binary search tree and what is the how does it work. So let's suppose. So yeah, let's suppose this is a node. Suppose the node is having 6 as an element. All right. You have some elements like 6, 7, 5, 3, 4. Some elements like this. Suppose first we are trying to create a tree by using this. Which tree? Binary search tree. So first element is done as a root node. Now, how do we insert the next elements? Let's see. Next element is 7. So where do we insert it? The number greater than the root must be at the right side, and the number that is less than the root must be at the left side of the root node. How? Let's see. See, this is 6. Now we have 7. So is it greater or less? It is greater. So it will go to the right of the root node. This is done. Now 5. Is it less than 6 or greater than 6? It is greater than 6. So it will go to the left side. Again, 3. Is it greater than 5 or less than 5? Less. So left side. So this is how it works. So this is something called as binary search tree. So how does it make searching easy for us? Let's suppose we want to search for a number. Let's say for example 3. All right. So when we want to go and search in the number in that binary search tree, we need not to compare that number with each and every node in the binary search tree. We will simply go, we will compare it with the root node. 3, is 3 greater than 6 or is 3 less than 6? So it is less than 6. So all the numbers that are less than 6 will be at which side? All those numbers will be at left side. So we will ignore this right side. We won't compare the elements. Those are present at the right side. We will just compare it with the left side. So we will then continue to compare do the comparison on the left side, that decreases the number of comparisons, the efficiency. So it leads to the higher efficiency and effectiveness. So this is how binary search tree works. So let's see how do we implement it by using a program. This is a C++ program. So yeah, we will first create when we are done with header files, the standard libraries. Then comes the creation of a tree node. We will first create a node. So struct node, we are creating a node. All right. In that we have something called a variable called as data of type int. We are just we are just declaring a variable that is of type integer. All right. And we have a node. All right. Then we also have it's pointed to left one, then right one. So what are we creating here? We are now initializing the value. The data that was of int type will be initialized whatever the value of val will. Then left will be null and right will be null. It means this is data equals to value, any value. We will be initializing it later. Now left one is null, right one is null. So what have we created till now? We just created a null, like empty null tree, empty root node, empty left node, empty right node. That's it. So let's go ahead. That is what we are doing by using struct node. I hope it is clear. Now, first we will try to insert something. We will try to insert a new node in our binary search tree. So how do we do that? First, we will need to check if our tree is empty. The first condition. So first we are creating insert method, a method that is named insert. Now we'll try to check if the tree is empty. If it is empty, we will insert a new node. So how do we do that? We are using if statement. If root equals to null pointer. If this root, let me show you. If this root is null, then we will return new node data. We will insert that data to our root node. All right. That is first condition. But suppose in case this condition is false, that means we already have some data in the root node. For example, we have 5 here. Then we will recursively insert the node, whatever appropriate data we want to do, to the appropriate subtree. How? Suppose we have 5 as our data element in our root node. Let's suppose we want to insert 4. Where will we be inserting 4? Left or right side? Is 4 greater than 5 or less than 5? 4 is less than 5. So we will insert the data at the left side. Let's suppose is in place of 4. So that is what we are trying to tell here. If data is less than root data, if the data we are trying to insert is less than root data, then we will insert that data to the left side. All right, we will insert that to the left side. We are inserting 4 to the left side. But if the case is, if this condition is not true, again, suppose if our data element is 6, So is 6 greater than 5 or less than 5? It is greater than 5, not less than 5. So we will go for else condition if this condition doesn't satisfy. So since it is greater than 5, we will insert that to the right. So 6, we will insert it to the right side. So insertion, we wrote a function to insert a new node in our binary search tree. This is done. Hope it is clear. Now let's move on to searching part. So the main thing we need to do is searching over here, right? So we are creating a function that is named as search. We are creating a search function. Its return type is bool. So what will it return? It will either return true or false. When we search for some data element, if we are able to find it, it will return what? True. If we are unable to find it, it will return what? False. That is it. So it has two parameters, the root and the data. Now we are checking if the tree is empty or not. If the tree is empty, then data will not be found. The simple thing. If our binary search tree have nothing in its node, so if whatever we want to find, 4, 5, 6, anything, any data element, if we want to find, and our binary search tree doesn't contain anything, then the data is simply not found, right? So that is what we are trying to write it in the code. If root equals to null pointer, that means root is already empty, root is already null, then it will return false. That means data is not found. That is the first condition. In case root is not empty, root is not null pointer, then we will go for these conditions. What? If root data equals to data, return true. In case suppose we have something like 5 in our root and we are trying to find 5 only, so then we will be trying to compare it, root data to the data we want to find. The data we want to find is 5 and in our root node we have 5. So is 5 equals to 5? Right, we found it, so it will return true. All right. Simply, if it is already in the data we want to find out is already in the root node, then we will simply return true. But suppose in case we want to search for 6, let's say, so then we will recursively search for the appropriate search subtree. How? See, if data is less than data, let's suppose we want to find out 4. We want to find out 4, if 4 is there or not. So let's see how this works. If data is less than the root data, suppose we want to search for 4, then we will first compare the data we want to, the element we want to search for to the root element. Is 4 equals to 5? Firstly, no. Now, if is 4 less than 5 or greater than 5? 4 is less than 5. This condition is true. That means data less than root data is true. Then we will return what? We will go to the left side. We will search the data. We will start searching our data element at the left side if it is less. Since the condition for binary search tree is that the left elements must be less than the root elements and the right elements must be always greater than the root elements. So that is how it works. But in case we want to find out, in case This condition is also not true. We don't want to find out 4. Let's say we want to find out 6. So what do we do now? Is 6 equals to 5? No. Is 6 greater than 5? Yes. If it is greater than the root node, then we will be searching it at the right side. If it is less, we will search it at the left side. If it is greater, we will search it at the right side. So now, since 6 is greater than 5, we will search it at the right hand side. Search root right. We will find the data. We will do it recursively. Recursion means we are trying to call the same search function again and again in the search function. Let me show you. The function name already is search. Within that function only, we are calling search once again. That is known as recursion, calling the same function. That is all about searching. Now, we will come to the main function. Node root equals to null pointer. First, we will initialize our binary search tree to null pointer. Now we will try to insert each and every elements in our binary search tree. That is, first element is 50, 30, 20, 40, 70, 60, 80. Our binary search tree have some elements now. Now we will try to insert function is done. Now we will search that data. Search. Let's suppose our search data equals to 40. So we will call that search method. How did we insert these elements in our binary search tree? We called the insert function. The insert function we created here. Here. We created this insert function, right? By using that insert function only, we inserted these elements in our binary search tree. 1, 2, 3, 4, 5, 6, 7. These elements. Now we are trying to search data, and what are we using over here? What are we calling over here? The search function. The search function we just learnt about. So if search root comma search data means if we are able to find this when we are comparing 40 with our data elements, if it is returning, since the return type of search function was bool, so if it is returning true, if this is true, then search data, that is whatever search data we write here, for example, let's say 40 for now, 40 will be it will display that 40 is found in the binary search tree. In case this gives false, all right, in case the search data is not found, then it will return 40 not found in binary search tree, return 0. That is it about binary search tree. See, 40 found in binary search tree. We give 40 as our data. Let's say I give 100 and I run it. Are we able to find 100 over here? No, right? So it will return 100 not found in binary search tree. This is how it works.